Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So, at first, we need to know why complex compounds exhibit color. So, in simple terms, the complex compounds exhibit color when there is available unpaired electrons in the d orbital of the central metal atom of the complex, which can transit between high and low energy level orbitals by absorbing and emitting certain frequencies of electromagnetic radiation. So, for example, if we have a degenerate d orbitals here, and if we have the d orbital splitting as high energy and low energy orbitals, so in that case, for example, if we have an unpaired electron in the um, lower energy level orbital, uh, which can actually absorb certain frequencies of radiation and can go to this higher energy level state, and then when it come back by emitting that radiation, this emission of the radiation is responsible for providing the color in the complex compounds. So if there is no unpaired electrons in the d orbital of a complex, uh, in that case, that compound will not show any color. On the other hand, if there is any unpaired electron in the d orbital which can undergo this dd electron transition, that that electron will be responsible for the color in the that complex. So here we are given two ions which are Sc3 plus and Ti3 plus. So at first we write the electronic configuration for Sc, which is the preceding the noble gas before scandium is argon, and then we write the rest of the valence electronic configuration, which is 4s2 3d1. So when we form Sc3 plus from this Sc, we have to remove all these three electrons, and the electronic configuration for Sc3 plus becomes only the electronic configuration of argon. So that means that there is no available d electron in case of Sc3 plus, and that's why these Sc3 plus compounds cannot show any color, or the Sc3 plus complexes are colorless. But in case of Ti3 plus, if we write down the electronic configuration for Ti, we see that um, the electronic configuration for Ti is Ar, and then 4s2 3d2. So now if we form Ti3 plus, first we will get rid of these two 4s electrons and then one 3d electron. So in case of Ti3 plus, we still have one unpaired electron in the d orbital, and this unpaired electron will be able to um, undergo this dd electronic transition, and this dd electronic transition is responsible for the color in Ti3 plus compounds.